Hello, welcome back. Calculus 1, Chapter 2. We're in 2.4. We were doing continuity, and we might need to do some more continuity problems. I like to check to see if a function's continuous. I like to find the points of discontinuity using the definition of continuity. So that's what we've been working on. I only did a couple problems with you, but moving on here to the end, just one of the consequences of continuity, one of the is the intermediate value theorem. So I just want to talk about this. So this is kind of a separate issue, but it comes from being continuous. So here's what this says. The intermediate, a little more math topic again for you. So the intermediate value theorem says if f is continuous on a closed interval a to b. By the way, as I read this, I might try to just draw a little picture. So I'm working on a closed interval from a to b. I want f to be continuous. Oh, look what they said. They want f of a not to equal f of b. So, there's a function value here called f of a, and there's a function value here called f of b, and they want them to be different. They want two different y values there. But the function has to be continuous in there, so who knows what it does, but it's continuous from a to b. And f of a is different than f of b. Okay, all right. And k is any number between f of, so k is a y value between f of a and f of b. Those are y values. So k is any number in between here. Who knows? There's k. Then, here's what the theorem says. If you meet all those requirements, then there is at least one number, maybe more, I guess, c, that lives in AB, so that's down here on the x-axis. There's a number c that lives in the interval AB, such that f of c is k. Okay, so in other words, there is a number c such that you can plug it in and get that y value. By the way, there may be more than one. Here looks like there might be another one. So, big deal. It seems obvious to me. We should work on a problem maybe. We could try to interpret, again, this is kind of formal mathematical language here. And I tried to explain what it means and how to read it a little bit. You could interpret it and say, if the function is continuous, and it's got these two on a, b, and it's got these two different y values, then it will attain every y value in between. That's what they mean when they say k is some y value in between there. I mean, if it's continuous, it should be able to attain any y value you want. And to attain that y value, it has to have an x value that gives you that y value. So you're guaranteed that there's at least one x, a c value, c is an x value that gives you this y value k. I don't know. There's this problem 101 in the book where they say here's a function, the square root of x plus 7 minus 2. They're working on the intervals 0 to 5, and they want to find the c value. So they say, the directions in the problem say, let me read these directions here. They say, verify that the intermediate value theorem applies to this indicated interval and this function. And then find the value of c that's guaranteed by the theorem. So first, verify that it is. Well, let's see here. Is it continuous on the closed interval 0 to 5? Maybe I don't know. Maybe I do know. I got a picture of this in my brain. I've been trained to, I know how to I could use a graphing calculator, some kind of graphing utility to help me. But I know that this is a square root function. It's been shifted over 7 to the left and down 2, down negative 2. So I think it's this square root function here. And so it actually is not defined less than negative 7. It's undefined. But for x values greater than negative 7, it's defined and it's continuous. It's a nice square root function. So from 0 to 5, is it continuous? From 0 to 5, I think so. I think it is. So I think we met that requirement. Is f of a different than f of b? Well, that's f of 0 and f of 5. Let's try to find those guys here. F of 0 is you plug in a 0, you get the square root of 7 minus 2. And when you plug in a 5, you get the square root of 12 minus 2. Well, yeah, those are different numbers. I might want to know what those numbers are. Let me just check that out. What is the square root of 7 minus 2? Approximately 0.65, approximately 0.65. And what is the square root of 12 minus 2? Approximately 1.46, approximately 1.46. So those are my two different y values. And according to the theorem then, I should be able, there is this x value that'll get me any y in between those. Oh, and then here, so yeah, so I can get this, the k value is a 1. They're trying to say, can you get that k value of 1? And it lives in 1, it lives in between here. So yeah, I can get a k value of 1. And find the c value so there is a c value guaranteed by the theorem. Now let's find it. So in other words, find out when this function equals 1. Let's try it. When does this equal 1? When does the function equal 1? So this is algebra, and you solve for x. I'm going to add 2 to this side. I'm going to square both sides. I'm going to subtract 7, and the answer is x equals 2. That's my c value. When c is 2, you plug it into this function and you get a 1. 2 plus 7 is 9. I should have done that in my head. 2 plus 7 is 9. Square root of 9 is 3. 3 minus 2 is a 1. Yeah, x is 2. That definitely gives me a y value of 1. I'm a little out of proportion here, but that's okay with my picture. Yeah. All right. So anyway, the intermediate value theorem is a consequence of a function being continuous. I feel like continuity was the big topic in 2.4. And then this is just an afterthought. Or why is continuity important? It guarantees this. By the way, you can use this to prove that there's a 0 of a function. You know, if the function's continuous, and one of your y values is positive and one of your y values is negative, then you must be able to attain this y value of 0 that lies between there. So one result of the intermediate value theorem is it guarantees a 0 between a positive and a negative y value if the function's continuous. So that's another example. All right, thank you for listening. Good luck on your homework.